Okay, we're going to talk about 7.4, which is determinants of matrices and Cramer's rule. So the first thing we want to talk about is a 2 by 2 matrix and finding the determinant of that. So I've got here matrix A, B, C, D. And in order to find the determinant, which the determinant is just a given number for a square matrix. So these only work for square matrices. So in order to find this, what we're going to do is we're going to take A times D. I kind of look at it as this diagonal. And we're also going to take C times B. And then we'll take the bottom number that I get from that. So AD minus this top number. Okay. So I kind of have a way I remember that. And we say multiply across. Okay, meaning diagonally. And then bottom minus top. Okay, so multiply across, bottom minus top. Now so that's for 2 by 2. For 3 by 3, we actually have two different methods. So I'll teach you the method I like best. I'll teach you that one first, which it goes back to this kind of cross multiplying bottom minus top thing. Okay, so the first thing we need to do is we need to take the first two columns and repeat it after this. So I'll again have A, D, G, B, E, H. Okay, so now I have a much larger matrix. And then we will take them and we will again multiply on the diagonals. So I'm going to take this here, multiply this one and multiply, and this one and multiply. Okay, so I don't really want to write all the letters up there, but then we will add those numbers. So I get this number, this number, this number. We will add it and get this number. Okay, then we're going to go the other direction, and we will multiply here, multiply here, multiply here. Now we've caught all these numbers. See, before I never caught D, but here is D, and I've caught it twice in the lattice work. So we have a number here, plus this number, and we again get a number. So we'll take bottom, which is this number, minus the top number here to get our determinant. Okay. So that's kind of the easier way, or maybe quicker way of doing this, but sometimes you do get really large numbers when doing that. So let's look at method 2. Now, method 2 is described in the book, and it can be a quicker way sometimes. So the first thing we're going to do is we need to talk about sign matrices. Okay, now the sign matrix is just the signs of any square matrix. So this one will be plus, minus, minus, plus, and we always start with a positive and they alternate in every direction. So for this next one, we'd have plus, minus, plus, minus, plus, and it would continue that pattern forever. And that kind of helps us in figuring out whether to add or subtract these matrices. So the first thing in method 2 is we're going to pick a row to expand this matrix upon. So just for this example, we're going to pick this first row. Okay, and if I want to expand it upon that row, kind of break it down a little more, we're going to see it matches with this because it's 3 by 3. So my first sign will be a positive. So we're going to go A. And then since we're working with this, we're going to cover up this row, this column, and I have this 2 by 2 matrix. So we'll find the determinant of that 2 by 2 matrix. Okay. Then we will move on to B, and B is negative, so we will subtract B, and again cover up this row and this column. So then we have D, F, G, I. And then we have to do C, which is positive, so plus C. And then the determinant, if I cover up this row, this column, I have D, E, G, H. And then we'll find the determinant of each one of these and add or subtract those to give you your full determinant. Now, this method's really nice if I have a bunch of zeros in here, okay, because I can expand upon any row or any column and expand into this 2 by 2 determinants. Okay, so this one is nice. We'll actually use both methods throughout. So then we have Cramer's rule. Cramer's rule is a method of solving systems of equations using matrices and their determinants. So I was going to do a quick example here of how this works. So we'll look at so let's say we have this example right here. Now we can split this up into 3 determinants. Okay, the first one is our coefficient determinant. Now that is just the determinant of your coefficients. Okay, then we have our determinant of x. So I'm looking for x. So instead of writing these variables, I'm now going to write these answers. So we'll have 1 minus 3, 4 minus 2. Okay, and here, instead of writing the y values, we're going to put in my solutions. So 5, 1, negative 3, negative 3. Okay, so we'll find the determinant of each one of these. Remember, the determinant is just a single number. We find that by multiplying across bottom minus top. So I get negative 10, negative 12. So it's negative 10 minus negative 12, which is 2. I get negative 2, and I get negative 12. So that's negative 2 minus negative 12, which is 10. Negative 15, negative 3, negative 15 minus negative 3, negative 12. Okay, now I still am looking for x and y. To find x, we'll take dx over d. Okay, so that's 10 over 2, which is 5. So x is 5. To find y, we'll take dy over d, which is negative 12 over 2, which is negative 6. So the solution to this is 5, negative 6. And we have that one finished up. Now we can expand this over many variables on the system. Okay, to do a 3 variable one, it's very similar. So you have your equations. Let's say we just have and then x minus y minus z equals 0. Negative 3x minus 2y plus 3z equals 10. Okay, so here's our system. And this time we'll have a d for my determinant of the coefficients. So 2, 3, 1, 1 minus 1 minus 1, and then -3, -2, 3. dx, again, instead of writing your x coefficients, or instead of writing this row, we now write the solutions. So -1, 0, 10, and then we come back to this row right here, to this column. So 3 minus 1 minus 2, 1 minus 1, 3. dy, so instead of writing your y column, you're now going to write these solutions. So we have 2, 1 minus 3, -1, 0, 10, 1 minus 1, 3. And then dz, we will have 2, 1 minus 3, 3 minus 1 minus 2, and then your solutions in the last column. Okay, and again, to find x, we will take dx over d. To find y, dy over d, and z is dz over d. Okay. And that's how we're going to set this up. I'll go ahead and finish it in the second part of this video, but just know how to find these. So remember, we can expand this over any row that we want, but we could also extend the numbers here and then to the multiply across bottom minus the top. Okay, so that is it for the first part here. So I've got a couple questions. How do you find a determinant? What is the sign matrix of a 5 by 5? And what is Kramer's rule? So here's some suggested problems that you need to write down and probably get started on those. So again, you can stop here watching the video if you would like, or continue watching to see some of these examples. All right, let's start off simply by finding some determinants of some matrices. So we're going to start with 2 by 2 matrices. So we simply multiply across. So that's 2 times 3 is 6. And -1 times -5 is 5. And we'll take our bottom number minus our top number. So the determinant of that matrix is a 1. Then this one we're going to multiply across. So you have 2 times 1 is 2, and 2/3 times 3 is 2. So again, you have bottom number minus the top number, and you get 0. All right, so I've got 2 of these. I'll do 2 different ways, these 3 by 3s. So the first method I like is extending. So we'll recopy the first 2 columns down, okay? And then we will multiply going in the diagonal. So we've got -3 times 5 times 3, -45. And then we have 7 times -2 times 2, -28. And then you have 4 times -1 times 1, -4. So a lot of times with this, it's nice and handy to have a calculator on hand to run some of these numbers real quick into the calculator. So we'll add those up. We get -77. Then we'll multiply this direction. So that's 40. 2 times 5 is 10, times 4 is 40. 1 times -2 times -3 is 6. And 3 times -1 times 7 is -21. So we'll add those up. Get 25. And again, we have bottom number minus the top number, which is 102. Okay. Now, again, this method works on all matrices, 2 by 2 and 3 by 3. When you get to larger, like a 4 by 4, I recommend using this next method, as it usually works out much better. So we're going to expand this on any row or column. I want to look for the row or column that has the most zeros, though. Okay, so if we look here, this column right here has the most zeros, so that's the one I want to expand on. And we have to know our sign matrix, as this will tell us if we will be adding or subtracting that number. Okay, so the first one, we start here with 0. Okay, and it's positive. So I cover up this row and this column, and I've got this 2 by 2 down here. So 4, 7, 5, 3. Okay, then we move to the next number. So subtract 1, and then I cover up this row and that column that it's in, and then I have these two numbers right here. And then we go to our last 0, which doesn't really matter. So we'll cover up this row and this column. So I have that top one up there. Okay, so now these determinants don't matter because we're multiplying them by 0. So this is the only one that matters. So we have -1 times, that's -3, 10. So it's -3 minus 10. -1 times -13, which is 13. So the determinant of this 3 by 3 matrix is 13. Okay, and we have a lot of uses for determinants. We're just going to look at a couple in this course for solving systems and doing some decoding stuff. Okay, so 4 by 4 here, we're going to look at this row right here. To find the determinant, we'll expand upon that. So again, we need our sign matrix. And this is a 4 by 4 this time. Okay, we're in this row right here. So that kind of tells us the signs of our leading coefficients. So we start with a -4. So minus -4. And then we'll have a 3 by 3 determinant. So we cover up the row and the column that number is in. So we cover up all those numbers, and I should have a 3 by 3 right there. Okay. So then our next number is 0, so we'll leave it out. So we'll put +0 just because we have that sign. And then we have minus -1, and we'll have a 3 by 3 there. So again, we cover up that row and that column there. Cross out all those numbers, and we're left with 1, -2, 4, -3, 9, 5, -5, 7, and 1. And then our last one is 0, so we don't need that. So really, we only need 2 parts there. Okay, so we can find the determinant of this one. Again, I don't care which method you use. Maybe now we go back to the repeat method or whatever you want to call it. Okay, so we multiply here, that's -12. Multiply here, that's 15 times 7, which is 105. And then 4, 9, and 2, 72. Multiply this way, that's 7, 6, and 4, 168. That's 2, 5, and -2 minus 20. 1, 9, and 3, 27. Okay, so we'll add those up. So I have 4 times This is 175. This is 165. So again, bottom minus top, you get negative 10. So it's minus 40. Okay, plus 1, and then we'll have to find the determinant of this right here. So that's 1 minus 3 minus 5, negative 2, 9, and 7. So we have negative 5, 9, and 4. Again, multiplying on that direction. So 7, 5, and 1. And 1, negative 3, negative 2. Add that up. You will get negative 139, 1, 9, and 1, negative 2, 5, and negative 5, so 50. And then 4, 3, and 7. You get minus 84. Which is negative 25. So negative 25 minus negative 139. You get 114. So you have negative 40 plus 114, which is 74. So the determinant of that one is 74. A lot of work, but again, it's simple math. We're multiplying and adding and subtracting. So we want to solve using Kramer's rule. I already did one like this, I believe. Just want to make sure I didn't do, nope, I didn't do that one. So we need d, dx, and dy. Okay, d is your coefficient determinant, so that's 1, 3, 2, 1. dx is, instead of writing your x's, you're going to write your solutions in there. So 1 minus 3, and then you'll come back to your y's. And dy is, instead of writing y's, you write the solutions. Okay, and you need to find the determinant of each one of those. So 6 and 1. 1 minus 6 is minus 5. 1 minus 9. 1 minus negative 9 is 10. Negative 3, 2. Negative 3 minus 2 is minus 5. So in order to find x, we want dx over d. To find y, we want dy over d. So dx was 10 divided by minus 5 is negative 2. And dy was negative 5 over negative 5, which is 1. So you have negative 2 comma 1. Okay, so this can be a really, really quick way of finding the solution to your system. I'm using some quick matrix work. Okay, let's do a 3 by 3 here. So again, we need our coefficient matrix. So 3, 5, 1, negative 2, 3, 1, 3, 8, 3. dx. So instead of writing x's, we're going to write our answers. And then I like to go back up to this D matrix. dy is, instead of writing y's, we now write the solutions. So my x's are fine. Then I go to the solutions. Then I go to z coefficients. dz. Your x's are good. Your y's are good. Your z's now become the solution. Okay, so we'll find the determinant of each one of these. So we'll repeat the rows. Okay, and then we will simply multiply on the diagonals. Again, calculator is really handy for some of this quick math. And then 3, 5, and minus 2. And then go the other direction. Okay, so you have 9 plus 24 plus negative 30. That's 3. Negative 27 minus 16 plus 15 is 26. So you get 26 minus 3 is 23. Go in here. That's minus 27 minus 16 minus 6. 9, negative 24, 12. Again, it's going to help to be proficient with simple multiplication. So then you have negative 49 minus negative 3 minus 46. Multiply this one. Negative 18 minus 24, 15 minus 6, 24, negative 45. So then add those numbers together. You get negative 27 up here. You get negative 27 down there. So negative 27 minus negative 27, you get 0. And then the last one, which is nice because that bottom row is all ones. So you get negative 9 minus 6 minus 10, negative 25, 9 plus 4 minus 15, negative 2 minus negative 25, you get 23. Okay, so now that you have the determinants of each one of those matrices to find x, we'll take dx over d, which dx was minus 46 over 23, which is minus 2. Y is dy over dx, dy over d, which is 0 over 23, which is 0. And z is dz over d, which is 23 over 23, which is 1. So your solution is negative 2, 0, and 1. So a lot of work, but this is super easy. Multiplication, subtraction, division, that all works out. So let me put back up your questions and suggested problems. Okay, again, right here is a lot of suggested problems, just finding determinants and solving systems using the Kramer's rule. Nothing real too difficult. So if you got questions, let me know. As always, this is at THS, Mr. Jones, signing off.